Okay, AP Stats, we're going to do the second day of section 6.1 here today. You guys were supposed to do a check your understanding, and here go the answers. Number 1, the probability that x equals 2 is 0.138. Add up all the others, subtract from 1. The second one is asking you for the probability of getting an A or a B, and that is 0.819. And the third one, we made a histogram. Don't forget your title and your labels and scale your axes, and it is skewed to the left. Okay, now that we have looked at a probability distribution, it's time to analyze one. So the mean or expected value, those two are going to mean the same thing for us. Expected value has a special meaning. I think we'll hold off and we'll talk about that later. It goes like this: mu of x. A mu and an x. I'll do this a little bigger so that you guys can see it in your notes there. The mean, or the expected value of a discrete random variable, is not just the average of possible outcomes. That's where you might make a mistake. It also takes into account the probabilities of each one happening. So it's technically what is called a weighted average. A weighted average. Look, if I'm looking for the average here, I wouldn't add up 0, 1, 2, 3, and 4 and then divide by 5. That would be 5. That'd be 10 divided by 5. The average would be 2. That's not the center of that histogram at all. The center of that histogram is over here, isn't it? Because these are taller. So I would need to account for the probability as well while making this average. So, you ready for this? Here's your formula. Mu of x is equal to x sub 1 times p sub 1. The x value, like this 0, times its probability, 0.011, plus x sub 2 times p sub 2, plus, and I go all the way up until I get to x sub n times p sub n. There you go. Now, notice I didn't divide by n. That's because every one of these probabilities is a fraction. It's already over an n. So there's an n down there. I am dividing by n, but I just don't have to write a big fraction bar, okay? This, of course, comes from x sub 1, x sub 2, x sub n being in a probability distribution, right? And so P1 is the probability that goes with x1, and P2 is the probability that goes with x2, and P sub n is the probability that goes with x sub n. So as if I had a little probability distribution rocking over there, that's how I would find the mean. Now, I do like to show you guys the other version of the formula so you get used to the notation. I could also write it as sigma from 1 to n, the sum of all of the x sub I times p sub i's, which means the exact same thing. Okay, now, put a little asterisk right here because you guys this year have not been great when I say find and interpret something on a test. You find it, and then you just basically don't interpret it. The interpretation of mu of x is a mean, but it's not a value, it's an expected value, right? That's the name of it. It's an expected value. Now look what I'm about to say. It's not a value we expect to get. Okay, now that's me being contradictory, right? It's called the expected value, and then I'm going to say it's not the value we expect to get, but I mean it's not the value we expect to get on one trial, right? That's what it isn't. The expected value is a value you sometimes can't even get on one trial. Okay, just like probability in the last chapter being a long-term concept, mu of x is interpreted as the average that you would expect to get over many trials. Okay, so think of it this way. I give you all of your test scores back. I always round, right? So there are no decimals. But if I take all of your test scores and I take an average of them, I get a decimal, right? The expected value or the mean of a random variable, it's something that you expect to see as an average if you took many trials. Okay, so once again, sorry about the ghetto-ness of these notes. We're going to change this to 367. Then we'll go to book example on APGAR score. So let me bring the book in here. Earlier, we defined the random variable x for an APGAR score to look like this. There we go. Calculate and interpret the expected value of x. The calculation is fairly easy. 0 times 0.001 plus 1 times 0.006 plus 2 times 0.007 plus plus, plus. Just multiply all these together and add them. And you get 8.128. Now the Apgar scores go from 0 to 10, but because the probabilities are higher over here, that moves the average this way. See what I mean? 8.128. There's your little formula for it. If you're supposed to interpret it, here we go. If many, many bratty, ugly little newborns were randomly selected, their average score would be about 8.128. So you see what I mean? It's a long-term average. That's what I want you to think of it as, a long-term average if we did many, many trials. That's how you interpret the mean or expected value for a random variable. All right, I'm going to flip the page, and we'll go to the next video.